Hi, welcome to my video on Descartes' rule of signs, part 2. Descartes' rule of signs is for the number of positive and negative real zeros. And let's look at what about the imaginary zeros. So if you have a p of x is x squared plus 4, so the p of x is x squared plus 4, then if you make the p of x equal to 0, that means x squared plus 4 is going to be equal to 0. So we find the values of x that will make the polynomial 0, so we'll solve it. X squared equals negative 4. The square root of x squared is plus or minus the square root of negative 4. So x is plus or minus. Square root of 4 is 2. The square root of a negative number is an I. So notice we have two imaginary roots. And notice if we want to make this equal to 0, then there's no real numbers to do it, because no matter what number you square is positive. So a positive plus a positive is a positive. And besides that, the sign change is, there's no sign change on the p of x, so therefore there's no positives. And what about x squared minus 2x plus 6? Well, if you let p of x equal that, and the p of x is equal to 0, so that means that x squared minus 2x plus 6 equals 0. Now we can solve this by, we can't, factors of 6 will never give us a 2, so we can solve it by completing the square root of quadratic formula. Quadratic formula, ax squared plus bx plus c, where a is 1, b is negative 2, and c is 6. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So b is negative 2, so it's the negative of a negative 2. B is negative 2. A is 1. And C is 6. All over 2 times 1, which is A. So that gives us negative of a negative is a positive, plus or minus. Now I want to work out this right here. Let's go up here and work out the inside. So a negative 2 squared is 4 minus 4 times 1 times 6. So that's 4. Subtract. That's 4 subtract 24. So that's a negative 20. So that's the square root of a negative 20 all over 2. And that's 2 plus or minus. And the square root of a negative 20, 20 is 4 times negative 5. Square root of 4 is 2. Square root of 5 we can't do, but the square root of a negative number is an I. So that's 2 root 5I. And we divide it by 2. So 2 divides into 2 once, and 2 divides into this 2 once. So again, notice that there's two imaginary roots, 1 plus root 5I, 1 minus root 5I. And you notice that these are imaginary roots. Again, there's no real number that will make this equal to 0, only the imaginary I numbers. And again, there's two of them. There's a plus or minus 2I, and there's 1 plus or minus root 5I. So the imaginary zeros are in pairs. And also notice, just to mention it, that positive 2I and a negative 2I are the conjugates of each other, because their product is going to be a real number. And if you, right here we have 1 plus root 5I, and we have 1 minus root 5i. So notice the 1 is the same, but the last term of these two binomials, 1 is plus, 1 is minus. So their products is going to be positive. And I just want to illustrate that. 2i times negative 2i. 2 times negative 2 is negative 4i squared. But I squared is negative 1. So that's positive 4. Again, that was done in imaginary numbers, which is a unit that I did. So we have imaginary zeros when we can't get any real numbers. So let's continue now to show you about the real zeros and imaginary zeros. The leading term of the p of x is x squared. So the total number of zeros is 2. So you have 2 zeros because it's the highest power. So if we have 2 real roots, then we have no imaginaries. If we have no real roots, we have 2 imaginary because there's always 2 zeros or 2 roots. If we have a cube, x cubed, we have 3 zeros. So we have 3 zeros, or we go down by 2, or 1 0. If we have 3 zeros, then we have no imaginaries. If we have 1 0, remember the total got to be 3, we can have 2 imaginaries. So there's always, the number of real roots and imaginary roots always adds up to the highest power or exponent of the polynomial. So we have a power of 4, so we have 4 zeros. So if we have 4, we could have a 4, we could have a 2, or we could have a 0. So if we have 4 reals, we have no imaginaries. If we have 2 reals, we can have 2 imaginaries. If we have no reals, we have 4 imaginaries. Because again, the total is always 4. Let's continue. I'm going to use this when we continue with the videos on finding the roots or the zeros of an equation. If we have again the same, what we just had, so this time we have x to the 5. So the total zeros is 5. So we have 5 reals, or we have 3 reals, or we have 1 0. 1 real. And we have 5 imaginaries, 5 roots. We have 5 reals. Total is 5. We have no imaginaries. If we have 3 reals, then we need 2 imaginaries because 3 and 2 makes 5. If we have 1 real, then we have 4 imaginaries because 4 imaginaries, there's 2 pairs here. There's 2 and 2 because they come in conjugate pairs, and there's 2 here. So that makes 5, and that makes 5. And if we have 6 zeros, which is this power x to the 6th, we have a 6, we have a 4, we have a 2, and we have a 0. If we have 6 reals, we have no imaginaries. If we have 4 reals, we have 2 imaginaries. If we have 2 reals, we have 4 imaginaries. And if we have no reals, we have 6. Notice the total of these 6, 6, 6. So, knowing that, let's complete what the possible zeros and imaginaries are on this equation. So we're looking at this equation. So notice when we look at the signs, we're looking at the positive now. There's no change here, and there's 1 change here. So there's 1 positive real. Now, I'm going to do the p of negative x. So I'm putting a negative x in the place of x. And I'll show you it this time, and then I'll take a shortcut. Negative x squared is the same as x squared. 2 times negative x is negative 2x, and a negative 15. Now, right here we got a positive to a negative, that's 1 change, and negative to a negative is no change, so we have 1 negative. So we have 1 positive, we put the negative x in, we have 1 sign change. So notice we have the total is the 2. Because this is square, highest power, the total is going to be a 2. So if we have 1 positive and 1 negative, it means we can't have any imaginary roots in this equation. Okay, let's continue. F of x is the same as the p of x. Again, we're checking on the number of positives, the number of negatives, and the possible number. These are possibles. So let's deal with the positive reals. 1, 2. So there's 2 sign changes. So there's 2 positive reals. Now, I'm going to do the negative, but I'm not going to put like I did here. I'm just going to say, if I put a negative x here and cube it, I will get a negative. If I put a negative x and square it, I will get a positive x squared. So that'll make it a negative, because a negative times a positive is a negative. If I put a negative x here, that'll make that negative. And that's a positive. So notice I didn't put them in like here. I just eyeballed it and worked it out. No change, no change, but there's one change here. So there's, as we said, 2 positives from the initial. When we put the negative x in and worked out the powers, we got negative, 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 positive. So there's one change here. So the total is 3. We have 3 is the highest power, so total is 3. So we got 2, 1, and we can't have an imaginary. Remember, the imaginary roots, imaginary zeros or roots, got to come in pairs. So we can have none of them, we can have 2 of them, we can have 4 of them, 6 of them. But we can't have one imaginary zero or imaginary root. We got to have 2, 4, or 6. Okay. And what about, we can also have a 0. We have 2 reals or 0 reals. So we got 0 reals, and we have 2 positive reals or no. And we have 1 negative. That's all we have. So we have no positives, 1 negative. So we have to have a total of 3. So we could have 2 imaginaries. So it's possible for this equation to have 2 pluses and 1 negative, or have no pluses. It could have 1 negative real root and 2 imaginaries. Okay, let's continue. Practice that. We have to keep practicing it. Here we go. Complete the table. So h of x, a polynomial. So let's see what we have. 1 change, 2 changes, no change. We have a 3. So we have 3 positives. So if we have 3 positives, we can also have 1 positive because it goes down by 2. Now, how many negatives? So what about negative x to the 4th power? Negative x to the 4th power is a positive. Negative x cubed is a negative, and a negative is a positive. Negative x squared is positive, so that makes that positive. And a negative x here makes it a negative, and this is negative. So in terms of the negatives, we have no change, 1 change. So we have 1 negative. So we have 3 reals. Remember now there's 4 roots, 4 altogether, 4 is the total. So we have 3 positives, 1 negative, we have no imaginaries. But if we have 1 possible negative, we can have 1 positive real. If we have 1 negative, that's 2 altogether, 4 is the total, so we can have 2 imaginaries. So again, in this equation, we could have 3 positive reals, 1 negative real, and make 4 total. Or we could have 1 positive real, 1 negative real, and 2 imaginaries, make 4 total. Okay, let's continue. You can pause the video at any time. Let's look at the positive changes. We got 1, 2. So the positive changes here are 2 or 0. Now, how about the negatives? So we put a negative x here, we get a positive. Put a negative x here, and we get a positive. And that's a plus 7. So there's no negatives. No negatives. There's only 2 of them. So if there's 2 positive reals and there's no negatives, there can't be any imaginaries because the total is 2. And we got 0 positives. We have no negatives. That means we must have 2 imaginaries because the total is 2. So the total got to be this power. So the total at the end, when you add these up, got to be the highest power of the polynomial. And we have number 5 here. Notice we have x to the 4th. Right away I can put power of 4 in. I have 4 zeros. So let's check the positive one. There's a positive to a negative. That's 1. Now, we got 1 positive. Let's see. Okay, we got 1 positive. So we got 1 positive. Okay. Now, let's change the sign. Put negative x in here. I'm just going to do this right now. So that gives me x to the 4th minus 1. So when I put the t of a negative x, I'm putting negative x in. I did put negative x in. That gives me x to the 4th. That gives me the same as this. So there's 1 negative. Okay. So I got 1 positive from here. I got 1 negative from here. 4 is total. So I must have 2 imaginaries. So I got 1 positive, 1 negative, and 2 imaginary. I'm going to illustrate that now, just for a bit of fun. Let's say you were given this equation and you wanted to find the zeros. So we make the polynomial equal to 0. So what we're saying is that the t of x is equal to 0. To find the zeros, we make the t of x equal to 0. So we make the right side equation equal to 0. Notice that this is the difference of 2 squares. It's an x squared and an x squared. Factors of 1 are 1 and 1, and we have a plus and a minus. So that means that x squared plus 1 equals 0, or x squared minus 1 equals 0. So if x squared equals negative 1, the square root of x squared is plus or minus the square root of negative 1. X is equal to plus or minus I. And if x squared equals 1, the square root of x squared is plus or minus the root of 1. X is equal to plus or minus 1. So notice we have positive I, we have a negative I, we have a plus 1, and we have a minus 1. Notice we have 4 roots. 2 are imaginaries, perfect. 1 is positive, perfect. 1 is negative. So, knowing about the sign changes and if you're going to have how many possible positive negatives helps you to narrow down your zeros you're going to have. And before we finish, I just want to mention this. Every odd degree polynomial has at least one real zero. Let me explain. Imaginary zeros are in pairs of 2, 4, 6, 8, etc. So if you have a polynomial with a degree of 1, you have one real zero. It means you have no imaginaries. Your total is 1. If your degree is 3, you have 3 real zeros or 1 real zero. So if you have 3 reals, you have no imaginaries. Your total is 3. If you have 1 real, you have 2 imaginaries because your total is 3. If you have a degree of 5, then you could have 5 positive reals, 3 positive reals, or 1 positive real. If you have 5 positive reals, you have no imaginaries, but your total has to be 5 zeros or 5 roots. If you have 3 reals, then you have 2 imaginaries because your total is 5. If you have 1 real, you have 4 imaginaries to make up 5. 4 imaginaries means you have what? There's 2 and 2 because they're in pairs. So notice that if you have an odd degree of 1, you have 1 real root. If you have a degree of 3, you could have, again, 1 real root. If you have a polynomial degree 5, you have 1 real root. So note that when the degree is odd, you have at least 1 real root. The real root could be positive or negative, but we have 1 in, no matter if we got a 1, 3, 5, 7, 9, if it's odd, remember, if they come in pairs, then 2, 4, 6, 8. So if you have a 1, 3, 5, 7 degree of a polynomial, you'll have guaranteed to have at least 1 real root. So that ends our video. Hope you like my video and understand, because I'll use that table again and again and again when I'm solving polynomial equations. And if you like my video, click the like button, click the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.